So how do we write the names for acids and bases? Well, first be able to define an acid, which is going to be a compound that contains one or more hydrogen atoms, and when it's dissolved in water will produce hydrogen ions. Define base. Well, a base is something that usually can accept a hydrogen ion and often gives off a hydroxide ion when dissolved in water. Determine the names and formulas of acids and determine the names and formulas of bases. Of course, you should know several common acids and several common bases, just as general chemistry literacy. So what are acids and bases? Well, for acids, their cation is going to be H+, so that's going to be the hydrogen ion, which means when they are going to be put in water, they are capable of, as we say, donating an H+, which means an H+ ion is going to come off of them when they go in water. If you're looking at organic chemistry, you're going to see the CO2- group, and you see CO2-, and that would actually be CO2H, but of course they can donate an H when they're dissolved in water. So you might see this as like oxalic acid. You'll see that group on there. For bases, their anion is the hydroxide anion, and they're capable of accepting an H+, because H+ added to hydroxide makes H2O, which is just, well, water. And organic chemistry does a lot less with bases, so you probably won't see a lot of those if you take OChem. So acid names. All right, you want to write this down. This little chart here is going to be really helpful, and you're going to need to know this if you want to name an acid. So use the end of the anion to determine the acid name. So for things like your simple monatomic anions, you have "ide" at the end, like oxide or chloride or fluoride. So fluoride there, you're going to name it with the acid. It's going to be hydro, because remember, hydrogen is your cation. And then you're going to have your stem, like fluor, and then ic, acid. So hydrofluoric acid. This is going to be how you name things with an anion ending of "ide." What about ITE, like ite, like nitrite, NO2-. So then you're going to write the nitrite, you're going to take the nitrura, and you're going to add OUS, so nitrous acid. You're going to find nitric acid more often, which is, of course, the ATE ending. So nitrate, or in this case, sulfate, you're going to put the IC ending, so sulfuric acid. And if you're savvy, you might kind of recognize, wait, isn't this like the ferrous and ferric, or stannous and stannic ions? Well, yes, that's where the original names do come from, admittedly. So this is how you're going to name the different acids. And the number of hydrogens in those acids is equal to the charge of the anion. So nitrite would have a single hydrogen in nitrous acid, and sulfate will have two hydrogens in sulfuric acid. So some common acids in chemistry. There's hydrochloric acid, very useful for dissolving metals. Does form some non-soluble compounds with things such as silver and lead, though. Sulfuric acid is good for, well, just making other compounds. So it's used as kind of in more complex chemical processes, like even making, what's it called, high fructose corn syrup. Nitric acid, it dissolves most things. In fact, the nitrate ions are really good if you're using metals. So they also will dissolve metals pretty well. You'll see hydrochloric acid for dissolving things like iron, but nitric acid, I mean, yeah, it can dissolve most things. It just also gives off a toxic fume when it does so. So, be careful. Phosphoric and carbonic acid are both used in buffers, and we're not going to get into those too much, but when you do, if you ever do, just look back to these. What about common acids that you've already seen? Well, citric acid, it's found in citrus fruits, and it's a preservative. Ascorbic acid, we call this vitamin C. It can also be used as a preservative. Acetic acid, that's vinegar. And that's also used as a preservative, especially in pickling or sauerkraut. Well, actually, sauerkraut can be lactic acid, which is also found in your muscle aches, but can be used as a preservative. Now, you see a lot of these are preservatives. Well, why? Well, it turns out when you make something acidic enough, the number of molds and bacteria that are going to grow in it gets very low very fast. So it's hard to spoil things such as pickles. In fact, you'll actually add citric acid or ascorbic acid to things like jams and jellies to keep them acidic enough from spoiling. How about bases? Well, that's a cation name, and then the anion name. Most of the time, the anion is hydroxide, so sodium hydroxide, calcium hydroxide. These are both things that have just a metal and a hydroxide, and those are both very common bases in the laboratory. So some other common, these are the common bases. You also find them around the home if you're doing these kind of things, like lye. Sodium hydroxide is used to make soaps. And lime, calcium hydroxide, can be used to do things such as that, well, it actually can be used in pickling, interestingly enough, because the calcium helps keep the pickles crisp.